Kafka Stream demo. Okay, so let's look at this project. It's actually in another branch called Stream Top N Active, and this code is gonna be using Stream Kafka Stream to demonstrate the idea of basic stream capability of using Kafka cluster. So previously we already learned how to use the producer to create a message and to use consumer to read a message out of it. So it's a basic publisher subscriber model. So by using Kafka Stream, we can actually do more streaming data processing instead of just a read message and put message into the cluster. So what is stream? Basically, it is just like a context of the messages. Right? We have a huge amount of messages. We want to group them together, do some aggregations, group by, conversion, filtering. Um, all those things could be done by using stream process. There's a lot of different streaming process frameworks or tools, especially in the big data domain. But Kafka Stream is very, developer friendly, so we don't need to learn a whole bunch of data processing knowledge, and it's easy to be developed and plugged in into our existing Kafka cluster. It's also standalone system, so we don't need to do anything to the cluster. And we just need to create a Spring Boot project, and that project will be running on top of Kafka. Uh, so in this demo, okay, so first of all, it doesn't work in the Apple Silicon chips, right? So you have M1, M2, then you have to switch to Windows or Linux by using virtual machine or a remote cloud server. So maybe in the future the dependency issue will be solved, but at this moment, I didn't find an easy way to bypass the issue. Okay, so in this project, we're gonna have two modules or two projects. First is the producer, which is exactly the same one as the previous sections. This producer will keep creating user action event messages into the Kafka topic, and the action include user ID, action, and action data. Okay, so we can just quick look at it. And for our model, we have user action, and we have a user ID, have the action type, which is a string, and also we have action data, which is object. So the data doesn't matter in this demo. And so for the consumer, which is the different one. So the consumer not only just read the message, but also it can create a stream out of the messages. And then for this particular demo, we're gonna use Spring Boot, Spring Kafka, and Spring Kafka Stream, which is the same dependencies as the previous demo. And but for the streaming part is different. So we're gonna create stream out of the topic messages, and then the stream will be duplicated into two because we're gonna achieve two functions. One is to rank the user by their activity numbers, like the total number of activities in a timed window, like 30 seconds by default. This is we set 30 seconds. And another stream is to rank the activities, right? It's like from the user's perspective, how many activities the user did in the previous 30 seconds. Okay, that's one function. Another function is from the activities perspective. We have different types of activities. Which activity is the most popular one, right? So the user is doing the most in 30 seconds. So those are the two data. So you can see this kind of usage, we need to conclude all the previous messages, right, at a period of time. So this is called a context of your message. Your message is no longer a standalone message. It is actually has order, or it has timestamp, and also it will have aggregation to group by either user ID, or group by the activity types, right? So this is the usage, and then the Kafka stream will keep calculating this kind of data and then update the result set. And the result set could be put into another topic in Kafka, so that we can just read the data out of the topic, or we can use a local storage so that the data could be temporarily saved in the memory. And also this storage can be synchronized with the cluster, so that at any time we can shut down the system, and then when we restart everything, then the previous calculation is still there. Okay, so this is the demos about. And now we're gonna go through the code. So if you understand what it is, so you don't have to really look into the code at this moment. but let's just do it for now. Okay, so for the producer, it's the same thing, right? So we have a topic. Default is a test topic 2. We can actually change it to any name. But if you change this here, you have to change it in the consumer, right? Because they are using the same topic to put and get message. And in the system here, we just a regular Spring Boot using Kafka template to send the message. And then we have a scheduled job here. So to send the message every 100 milliseconds. So to send a random user event, right? So this is the method as the previous, same thing. Action type. So we have click, type, refresh, upload, go back, scroll up, scroll down. It's just some random fake actions there we use. Okay, so this is the producer. Okay, it's very simple. After we started, then it will just keep sending messages behind the scene, right? So in the background, you can see sending to the topic. It doesn't matter whether we have the consumer started or not. So the Kafka cluster will start, saving or buffering those messages. We can just go to our Docker and go to localhost 8080. So then it will open our Kafka UI. Okay, so here we can see our topics, and then that's the test topic 2, and it will keep having messages in it. Okay, then look at the consumer. Okay, so our consumer will have a, firstly a configuration. Okay, same configuration, topic name. Okay, just to make it consistent with the producer. And then in the main class, we have to just, if you know the previous section, right? So we use this annotation to read message from the topic. Now we don't need that. We need to use Stream API to let Stream API automatically get the message and also make conclusion and aggregation to the messages. So we don't need those two. Just make sure you comment out those. Okay. But if you don't comment out, it still doesn't matter, right? So because they are just gonna just print whatever they want. But just let you know, we can use both functions from cluster from Kafka at the same time, so they don't have any conflict. Then we're gonna have instead of this, we're gonna have a config of our Kafka stream. So make sure you have this annotation enable Kafka streams there, and then for those configuration we already talked about yesterday, last session. And here we're going to have one more, which is our default Kafka stream configuration. So basically it's to indicate where the server is and what kind of application this stream is. And then the basic default serializer and a deserializer, okay, of our key and the values. So this is a very simple config here. And the next is we're going to create an automated processor for our data. Okay, let's just stop this producer first. Okay, and then in here we have a component bin. Okay, it's called action user action event processor. We inject our topic from the application property file, use the @value annotation. Okay, we have an object created. So this is a window size. That's default 30 seconds. Okay, so this could also be customized. You can just put 30 into the properties like this way, inject it to here, right, and then set it. And here is the main method that we will be using. Okay, so this pipeline, okay, and we auto-wire object into this method, and then this object will be created automatically by the Spring Kafka stream builder. Okay, so then this stream builder will build a stream out of our topic using this key serializer, deserializer, and this value serializer, deserializer. Okay, so the key is our user ID. Value is our user action event itself. Okay, so the user action event look like this. Okay, so here it is, user ID, action, and data. And then we have the offset reset policy. So here we have the latest. So it will just read the latest message out of the topic instead of read everything from the beginning of the topic, right? So the offset is set to the latest. So it means that like just now we send those many message from the producer, it will be ignored. Okay, so only if we start the component, and then the component will start getting the latest message, okay, out of the stream. And we also have the, instead of latest, we also have the earliest. So that is the very old one, or you can just set your own value. Okay. Okay. So this, then after that we have the stream created, and then we're gonna create two duplications. Okay, one is to user stream, one is category stream. Okay, so here actually we don't need to use two, but just to make it like a more easy to use, you can use the existing one. Okay, that's also fine. And then we're gonna have a filter and create two streams, and then we process those two streams. One is used for user rank, one is for the category rank. Okay, so to process those two streams, okay, so the messages, you can just think of the way of Java 8 stream API, right? We have a Lambda functions, we have a stream, intermediate operation, terminal operation, we have a map, we have flat map, we have a filter, we have a count, we have for each, we have a group by. Okay, so for the user, for example, we want to group all the user ID, okay, all the messages with the same user ID into one group, and then count the value. Okay, so and then use the count as the value so that we can have a user ID as the key, and then the count is the value, right? Count of the total number of events as the value. But also we can apply a window, which is 30 seconds. We only count the current 30-second window, okay, as the valid message. Older, we don't care, right? So that's the window. And we have different kind of windows in the how is that in the Java, sorry, the Kafka stream. So we have different concepts of different windows, sliding windows, timed windows, session windows. Those are the knowledge that we need to, get too deep into, but not today. Okay, maybe you can just learn it from the document or from, if you have some data processing knowledge. Okay, but anyways, we can just use the easiest one. Okay, so timed window, 30 seconds and group by key. So here, this firstly, we group all the messages by its key, which is the user ID. Okay, and then those two, okay, are how you're gonna serialize and deserialize the key and the value. Okay, so here this is the deserializer. We use our customized serializer, deserializer. Okay, SerDes. So then this is used for serialize and deserialize our user action event. Okay, so it's because it's a distributed system, so the message will be passed here and forth. So we need to provide how to serialize and deserialize the value and the key. Okay, the key is string, the value is a customized class, so that's why we need to customize our own SerDes. Okay, so very simple, easy, and in the end, we're gonna materialize the result into a local storage. Okay, as the name. Okay, so this is called a state store. You can say materialize a state store with a given name. This is the name. Okay, you can think of it as a hash map in the memory. Even though it's more like dedicated, it can be persist into the cluster. Okay, so here we have a basic same idea. We just use the state store to save our result. Okay, so you can see this result is gonna keep updating because the messages keep coming and the time is keep growing, right? So then we need to just keep updating this mess, but everything is automatically done. We just need to declare the stream, the pipes, the pipelines, okay? Or we can call it the topology, okay? So this is the topology of our flow, okay? And then the category is the same thing, okay? So but instead of categorized by the key, we need to do a map first, right? So the Java 8 map is the same. Stream API map is the same, right? Convert from one type to another type. Okay, so for here, we're going to convert our key value pair into a new key value pair. Okay, so previously is the user ID is the key to the user action. Now we want to convert it into the action is the key, and then the value is the value original value. Then after we have the action as the key, then we'll group the key. Then all the actions will be together, and then we count how many actions are done in 30 seconds. Right. So it's two very simple basic group by for the streaming process. Okay. So now after we declare this, we start the consumer. Then those two state store will be there in our system. Okay. So then we need to provide an API or use it. Right. So use the data. So the API is here. It's a regular RESTful API. Nothing special. We talked about this already. I have a get mapping top n and get mapping event rank. Okay. So top n, it uses the user action service. Then this service will used for tra traverse through the store, right? So the state store. Okay. And then now again, this service is taking advantage of Kafka Stream to query the store to get the records from it. Okay, so because these records will keep growing in the store as well, right? So every 30 seconds, and it will calculate a new bunch of records. So then you have to also decide from where you start reading it. So here again, we have a fetch of the latest 30 seconds data. Okay, this is because our stream is calculated every 30 seconds. So it makes sense to get the latest 30 seconds records. Okay. Um, and then here we have a priority queue in order to sort the value. Okay, so that's a very simple core Java. We don't need to dive too deep into it. Okay, so but in the end, we're gonna get a result which is a sorted version of the record inside our state store. Okay, and also we have a time constraint, like we just need the latest 30 seconds data. Okay, we don't want the old data. Okay, so here, those are the two services. Okay, so we're not gonna go too deep into how each individual method is doing, but you get the idea. And now we can actually start the producer and then start the consumer, and to just take a look at what it look like. Okay, so in the API. Um, okay, you can see there's a lot of skipping. Okay, for expired window. Okay, it's because we have so many records in the queue. So then the consumer will firstly start to skip all of them, right? So because they expired the timestamp for each message in the Kafka cluster, okay, it will have a timestamp. Okay, okay, you can see here. Okay, so then the consumer will use timestamp. Okay, so to do the calculations. Okay, so we can go to our API localhost 8080 slash top n slash, let's see, 10. Okay, and then here you can see we have ID 84 count 4, right? ID 93 count 4, ID 48 count 3. So you can see if we keep refreshing, the data actually keep changing. Okay, so because our testing data, the producer is keep sending messages and every 100 milliseconds. You can see for every 30 seconds, the whole record will be recalculated. Okay, so it's not a sliding window. It is just like a window, timed window. You can think it's like every 30 seconds, we're gonna calculate everything, and then we're gonna move to the next 30 seconds. Okay, so we're gonna refresh the whole records. If you don't want that, you can just change it to a more dedicated window instead of just a timed window. You can have a session window or sliding window to make it more like, instead of this kind of jumped uh, or have a stair, right, of the records. But anyways, so that's the first API. The second API is the event rank. Okay. So for the event rank, we're gonna have an event, right, and then the maximum number and sort it. Here are 42 go backs, right, and 44 go backs, 40 type, 34 upload, right? So in this, we can expand this time period into 1 day or 1 week so that we can have different ranks, right, for different things. You can see every 30 seconds, it will just refresh the whole ranking. It is because, the previous explanation. You can see here. Okay, so then these records keep changing and it's automatic and also it is stateful. So it means that the Kafka cluster, your consumers, they know, okay, from where to start, and also it won't redo everything. If we start a new consumer, then the new consumer will just coordinate with the existing consumers. Um, so it is a more, how say that, like distributed and scalable, then you just do everything by yourself, right? You can see how can I do it all by myself using regular Kafka listener. Okay, uh, it technically it can, but it will take a lot of time for you, for example, to apply this window. Okay, so this window size and how you stream, how you create multiple streams or branches. Uh, so this branch is another way that we can create our topology. Okay, so we can create branches. This is like a tree structure. Okay, from beginning of our stream, and then we can have multiple branches, and then the branch can be merged back. Okay, so those are the branch concepts. But for our demo, we just need two separate streams. So we just use the filter method here. All right. So that's that for this part. Thanks.